afternoon. Welcome to WASA Distance Education Center and PLAR Science. So this is our second class for this week. So it is still week. Let me just get my pen here. We're still on week 4, and today is Wednesday, May 8th. It's not too late to register for courses. So remember, there are several people who can help you with that. You can check with your local DEC, or you can contact Candace, especially if you're wanting your PLAR assessment. You can talk to her, or you can contact Michelle here at WASA. We also have available our WASA sign up electronically, so you can check that out. All you need is an email address for you to sign up. So remember, that's just an electronic application form. So if you don't have a hard copy, you can use that to sign up for courses. So you can still sign up for independent learning, but remember, you have until June 13th to complete it. There is a deadline for students who are graduating. I believe the date for that for those students is June 11th. That's what's been circulating. You can expect regular contacts by phone, email, or if you're using Facebook or social media that you have identified for your teacher to contact you, then they will reach out to you there. Term 3 is from June 24th to August 22nd. So we do have designated markers for students who are or will be taking courses for term 3. So again, you can contact your DEC, Candace or Michelle, if you want to sign up for term 3. Continuing with term 2B, we will be having 2 draws. So 2 student draws, one for students who earn a credit and one for students who submit work. So make sure that you submit your work to your teacher so that your name or names will be entered into the draw. Students working on more than one course, of course, will have their names entered for each subject that they submit work for. So if you're working on your PLAR Science or your PLAR Math, then each lesson that you submit will be entered for those subjects and lessons. Okay, so so it says here week 5 and it says lesson 3 chemistry. So obviously we're not really quite ahead because we will be missing one of the classes. So if you check your calendar, Monday the 20th, that's on week 6, we will not have a class as that is a holiday. Okay, so we're not really ahead, but we won't be behind either. Students who have their culminating activity, please send them back. If you do not send them back, then I cannot complete it, or mark it, and you will not be able to get your equivalent credit. So remember, even though you complete all 5 lessons for PLAR Science, if you do not complete your culminating activity, then you will not be granted the equivalent credit. So if you still have it, complete it and return it to me for marking. Okay, lots of ways to contact me. This is on the first page of every lesson for PLAR Science, so make sure you check those out. Options for submitting your work. As I mentioned, you can have your DEC do it for you. She or he can fax it or scan email to studentwork@nnec.on.ca. Make sure that you are also CCing to the teacher that's marking your work so that we are aware that you have submitted something. You can do it yourself by using your Notes app to scan email it. Popular format for students is sending a picture through Messenger, or if you want to, you can also use your scan feature. So you can still scan it and send it to Messenger. The advantage to that is you do not get the background, so you just have the pages or the page itself. Or Another option is if you drop it off at our WASA office. So there's also an outdoor mailbox, or you can just simply knock on the door and someone will take your key questions or assignments from you. If you can't make it for classes, or if you're having problems, or you would like extra help, different ways again you can contact us, so either myself or Bonnie for any of the PLAR subjects, or you can go to YouTube. You can check out our profile, J. Mercer WASA for the PLAR History, Geography, and Science, and then PLAR Math and English is B. Osmond WASA. So remember, all PLAR packages are the same, so it doesn't matter if you registered in Radio, Zoom, or IL. You can continue where you left off. If you go to YouTube, there are playlists for each subject. Now you will notice that PLAR Science has two playlists. One is PLAR Science 2A 2023. These are for students who are working ahead. So right now we're just starting lesson 3, which is chemistry. So if you're working ahead, lesson 4 or 5, you can go to PLAR Science 2A and you will find the classes there with the key questions. And if you don't have access to Wi-Fi or internet, you can also request for a USB of classes. Again, you just need a USB port to insert the flash drive so you can view the classes. Okay, so this is what lesson 3 and key questions chemistry looks like. Again, everything is there for you, from the number for the studio, the Zoom link, office numbers, fax numbers, Google Classroom codes, one for NNEC schools only and one for your personal account. So remember, there are 2 separate codes. So if you try to use your personal account with the Google Classroom code for NNEC, it will not let you in there. It will say you need a different code or access is denied. And if that happens, just let me know. Okay, someone asked me this question today, support questions, but eventually the student realized it says do not submit for marking. So that's just for practice. When you see support questions, just try it out, see how you do, because the answers are at the end of the lesson. So we have key questions 41 to 63 to complete for lesson 3. So we only have, chemistry is one of the longer ones. It has 24 key questions, but you'll get a break because in lesson 4 there are only 8 key questions and lesson 5 only has 9. Okay, so this is the one of the longer ones besides lesson 1, which is astronomy. So we're going to review page 3, particle theory, and then we'll go on to states of matter on page 4, change of state on page 5. Page 7 is classification of matter. Page 9, pure substances and mixtures, and page 11, types of matter chart. And I think we might get as far as page 12, which is properties of matter. Learning goals, so keep this in mind while we're doing the lesson. I can explain the statements of the particle model. So remember the particle model, this is just, it's the way scientists explain how particles stay together as matter and how particles behave when matter is in different states. And then I can understand how matter is classified into pure substances and mixtures, so we will be looking at that. Okay, quick review. We did this from our last class. What is chemistry? So chemistry is a branch of science, and it studies what everything is made of and how it works. Okay, that's just a simple way of describing what chemistry is. In your book, it says chemistry is the area of science that looks at the composition, structure, and properties of substances and the physical and chemical changes that they might undergo. Okay, so simpler explanation, it just studies what everything is made of and how it works. So why is it important to study chemistry, or why is chemistry important? Because it's used all around us. If you think about it, doctors use chemistry to make medicine because it helps us when we are sick. Engineers use chemistry to make electronics like your television and your cell phone. Farmers use chemistry to help their crops to grow so we can have food. And chefs use chemistry to cook delicious meals. Then we also looked at what is matter. Now matter, that's just the stuff that's all around us. So if you look around you, it could be your computer, it's the air that you're breathing. Maybe you just had your lunch, so your lunch is type of matter. Even you, okay, you're made up of matter. So when you study chemistry, you will learn all about matter and its properties. Okay, so let's look at the particle theory. So I just mentioned that this is the way that scientists explain how the particles stay together. It also helps to explain behavior. So science always uses models to help explain behavior. And in the particle model, the first statement tells us that all matter is made up of tiny particles. So everything that you see that's around you is made up of tiny particles. So if you're looking at the slide, you can see the chalk that's on the table. So that chalk is made up of tiny particles. Second statement says all particles of one substance are the same. So if the particles of a solid matter, that's all made out of that solid. If it's liquid, all of that is made of liquid. And then if it's gas, so that substance is gas, then all particles of that substance are made of gas. Okay, number 3, different substances are made of different particles. So we have neon gas, oxygen gas, and ammonia. So all these are different substances, so they're made of different particles. And number 4, the particles are always moving. So the more energy the particles have, the faster they move. So if you're watching the slide, you can see that the first, the second, and the third, so I've marked it A, B, and C. If you look at A, and look at the temperature for A, so I just marked 0, so you could see where the 0 is on the thermometer. So the first one is 5 degrees. Okay, and that's in Celsius. You can see there's C for Celsius. Okay, the temperature for B is 20 degrees Celsius. And if you look at C, the temperature for that particular one is 40 degrees Celsius. So you can tell which particles are moving. Okay, they're all moving, but the more energy the particles have, the faster they move. So you can tell that C, which is hotter, is moving quite a lot faster. The particles are just bumping into each other. Okay, so they're moving faster compared to A. So A is only 5 degrees and it's moving slowly. Okay, here's a scenario. This is the best way to explain about the particle theory of matter. where we're talking about that matter is always moving. So someone with a peanut allergy, some people can get an allergic reaction from smelling peanuts. Okay, so this shows that even though someone is not near matter, they can smell it because its sublimated particles are continuously bouncing off air molecules. So what happens then is that the particles then bounce into your nose, which allows you to smell it. This also relates to the theory or fact that everything is made of extremely tiny particles that you can't even see it. You can smell something even though you can't see it. So even though you can't see the peanut particles in the air, you can smell them, and people allergic to them will react to peanut particles because it is matter. Okay, so that just shows an example of that statement. And finally, number 5, there are attractive forces between particles. So you can see that for gases, the attractive force is weak. For liquids, they are strong. And for solids, they are very strong. So the particles that are far apart, okay, their force is weak. The particles that are close together, their force is strong. So you can tell from the gas, the attractive forces are weak for gas. But with solids, where the particles are closer together, the force is stronger. Okay, turn to page 4. Here we have a particle model for a pure substance. It shows that it contains only one kind of particle. An example, gold is an element, so it's made up of only gold atoms. However, if you have gold jewelry, that's not pure because other elements are added to it to make it harder so that it wears better. Okay, but gold is a pure substance. Mixtures, these are substances that have more than one type of particle mixed together. So you have mixtures can contain atoms of different elements as well as molecules of different compounds. And we are going to look at those terms later, like elements, molecules, atoms. So all these different particles are mixed together but not connected to each other. And because they're not connected, they can be easily separated by methods such as evaporation, boiling, and filtering. One example is gravel. So gravel is a mixture of different types and sizes of rocks, so you can easily see the different particles. You can sort them. Or if you want to use the word, separate them. So sort or separate. Another example, if you have pizza, it could be considered a mixture, but if you look at the individual substances, you can separate them as pure substances. So if you have cheese on your pizza, that would be a pure substance. The pepperoni, that's also a pure substance. The mushrooms, pure substance. Olives. So the list could go on and on. Okay, and you can pick those out if you don't like them. Scientists divided particles into 2 categories. So they can either be elements and compounds. Eventually, scientists have evidence that elements and compounds could be broken down into smaller particles called atoms and molecules. Okay, and again, we're going to look at those terms. States of matter. So there are 3 states of matter. They can either be solid, liquid, and gas. So things that are around you, they can fall into those 3 states. So if you're, I'm looking at the computer, So is that solid, liquid, or gas? Well, that's solid. The book is solid. The mouse is solid. I have a drink here, so that's liquid, and so on. Okay, so um, you can sort them. Water is an exception because it can be found in all three states. It is usually found in liquid form. If you freeze it, then it becomes solid, and when we boil it, it turns into steam, which is gas. So let's look at the characteristics of each type of matter. So if you have matter that is solid, that means they have a definite shape and a definite volume. So all the particles are very close together. An example is a chair. A chair is a solid matter. So if you're looking at the slide, look at the particles in a solid matter. Okay, they're very close together. Liquids, on the other hand, they have an indefinite shape, but they have a definite volume. Particles are not very close together. So you can see there's liquid. Okay, and here's an example of water. And finally, we have gas or gases. Gases have an indefinite shape and indefinite volume. The particles of gases, they are very far apart and they move freely. So if you're looking up, you can see that the gas in its state, it's just bouncing around. If you look on the bottom of the screen, you'll see water is boiling. So you can see that's the gas. Okay? So let's do key questions 41 to 43. When you do your key questions, you can use this page where it says your lesson 3, the topics, the key questions, and the total marks. You can use this as a guide, as a checklist. So you can check which key questions you're working on. That way you know which key questions you have to complete, which ones you might be having problems with, and then you can contact your teacher, or if you want, you can watch the classes on YouTube. When you're working or trying to complete your key questions, you do not need, so it's not needed. Okay, you don't need internet access. Okay, or Wi-Fi. That means you don't need to Google your answers. Everything is in the book, unless it says in your opinion, because what I'm asking there is what do you think. But otherwise, first key question, what is chemistry? If you look on page 3, it tells you chemistry is the area of science that looks at, and so on. Okay, this is a hand question. That means you can put your hand or your finger on the answer. The 3 states of matter, we just did that. There are 3 different states. Okay, solid, liquid, and gas. That's all. 43, list the statements that make up the particle model. Now, some students get this wrong because they see on page 5 under the heading change of state, and there's 1, 2, 3, 4, 5. Okay, that's not what I want you to do for this one. If you read it carefully, look at the heading, then find particle model on page 3 as well. Very straightforward. List the statements, okay, or sentences that make up the particle model. Under the particle model, on page 3, it says first one is all matter is made up of, okay, I'll just do this one, all matter is made up of tiny particles. Okay, is made up of tiny particles. And that's it. So you're just listing them. All right, let's continue with our lesson. So we did key questions 41 and we did 41, 42, and 43. Now, as we're working on the lesson, keep in mind key question 44. It says give a definition for each of the following terms. So as you see it, you can work on them for your definition. So the word atom or the term atom, compound, pure substance, alloy, and so on. Okay, up next is change of state. So a change of state, so remember we have solid, liquid, or gas. So a change of state involves the addition or removal of heat energy. So these are the ways that substances can change state. They can do it in 5 ways. The first one is melting. So when it's melting, that means you have a solid changes to a liquid when heated. And a great example of that is snow or ice. Okay, so you have it in the solid state, but it's gaining heat, it's getting more energy, and it turns to liquid. So matters can change its state when it is cooled or heated. When a matter is heated, its particles absorb heat, energy, and vibrate or move faster. So you can see from solid to liquid. Okay, the second way is vaporization. This is where you have it changes from liquid to gas, and it happens when particles in a liquid gain enough energy to form a gas. So a liquid evaporates because some particles have gained enough energy to break away from a clump and escape into the vapor state. So particles that's near the surface may collide and be bumped out of the liquid. And you can see that when you're boiling water. You can see all the bubbles that's bouncing off each other. Some of it actually jumps from the pot and goes onto your stove. So evaporation occurs faster if a liquid is heated. When a liquid reaches its boiling point, so you can see the temperature on the bottom of the screen. Yes, water boils at 100 degrees Celsius. So when it reaches its boiling point, many gas particles escape at one time in the form of large bubbles. Okay, so that's the second way is vaporization. Third is condensation. So condensation is just a process in which gas changes into a liquid. If you have a cold glass and you take it outside and the air is warm, you will get condensation. Okay, you might even say the glass is sweating. Okay, that's what's happening. So water vapor condenses into a liquid after making contact with the surface of a cold bottle. Condensation is an important part of the water cycle, and it's the opposite of evaporation. So for condensation to take place, the air must be saturated and there must be a surface on which vapor can condense. So the cold glass, that's the surface That's where you'll find the condensation. During condensation, the molecules in the matter slow down. Heat energy is taken away, causing the state of matter to change. So it changes from gas to liquid. Remember, opposite of evaporation. Examples, so you can have a cold glass on a hot day. Okay, up next is freezing, where you have a change of liquid to solid. So now you have water as a liquid, so it cools and it becomes solid. So as heat energy is removed, the particles begin to slow down or move slower. This results in fewer particle collisions and a decrease in volume occupied by the particles. So that's known as contraction. When a liquid reaches its freezing point, so remember the boiling point is 100 degrees Celsius, water freezes at 0 degrees Celsius. So the attractive forces among the particles are so great that the particles are held close together. Okay, so that's what happens when water freezes. So you could have rain, so it might be raining and then it cools. So once you know that you are going to hit, or the temperature is going to hit 0 degree, then you know that you might be in for freezing rain. But we don't want that right now. Okay, sublimation. A solid becomes a gas when heated, or a gas becomes a solid when cooled without passing through the liquid state. So sublimation, this is the process where a solid changes phase and turns directly into gas, but it bypasses a liquid phase. Okay, so there's an example, dry ice. Okay, it's an example of sublimation. So these are the 5 ways that substances can change state. Okay, melting, vaporization, condensation, freezing, and finally sublimation. Okay, so now we can look at how matter. So remember, matter is all that stuff that takes up space, okay, and has mass. So matter is usually found in mixtures, which can be sorted into substances, which are usually compounds, which can be broken down into elements. Okay, or another way to look at it is you can have elements, which can then turn into compounds. We can and substances can be either elements or compounds, and then you have mixtures, and again you're still talking about matter. So how do we classify it? How do we sort it? Well, to study matter, scientists must be able to sort it or place it in specific categories. So we've already seen one way of classifying matter. We can classify it by its state. So we can classify it as either the chair is solid, the water is liquid, the air is gas. Most substances can be classified that way, so solid, liquid, or gas. All matter can be placed in 1 or 2 categories. They can either be pure substances or they can be mixtures. All known substances are made up of the smallest known particle, the atom. So here's what I mean when you come across a term, so in your book, and then you're looking at your key question, atom, so give a definition of each of the following term. We know that we just came across that one. So atom is, we can say, the smallest known particle. And you can underline definitions in your book. Once you receive the lessons, you can do what you want with it. You can underline it, you can highlight it, however you want to remember stuff, um, or if you want to mark it. So from the stars and the sun to your body to the clothes you wear and the food you eat, everything is made up of the smallest known particles, which are atoms. Okay, let's continue with our classification. Two types of pure substances. So if you have a pure substance, you can then break it down into either elements or compounds. So an element is a pure substance that is made from a single type of atom. Elements are the building blocks for all the rest of the stuff in the world. For example, iron is an element, oxygen is an element, hydrogen, gold, helium, these are all elements. Okay, so that's one way to classify matter is it's either a pure substance, and then under a pure substance they can be elements or compounds. If they're not a pure substance, the stuff that's all around us can be made of mixtures, and then we can break mixtures down into either heterogeneous mixtures or homogeneous mixtures. Okay, and we're going to look at that too. When atoms of different types of elements join together, they make molecules called compounds. So compounds are made up of, and this is important, so you can highlight it, mark it, or put it in brackets. So compounds are made up of two or more different atoms bonded. So if you don't want to use the word bonded, you can say linked, or if you want to say they're stuck together. So two or more different atoms linked or stuck or bonded together through a chemical reaction. There are only just over 100 types of atoms, but there are millions and millions of different types of substances out there. Just like we only have 26 letters in the alphabet, but you can find millions and millions of sentences, because you take all those letters and you put them together to come up with different words. So as I was saying here, there's just over 100 types of atoms, but you can have millions and millions of different types of substances out there, because they are all made up of different types of molecules. So molecules are not only made up of two different types of atoms, but they can also have different ratios. So for example, when we talk about ratios, in water, when you see water molecule is written as H2O, it means that water consists of compound molecules and is made up of the element hydrogen, but you need two of those, and the element oxygen, and you need one of those. So when you write it, it's H2O. So that's the ratio. 2 hydrogen, so 2 parts hydrogen, 1 part oxygen. Water will always have 2 times the number of hydrogen atoms as oxygen atoms. If you don't do the ratio properly, then that's not a water molecule. Okay, it has to be H2O. So anytime you have 2 atoms joining together, then you have a molecule. If you look at the molecule for sugar is C6, which means it has 6 carbon atoms. H12, it has 12 hydrogen atoms, and O6, it has 6 oxygen atoms every time. If you want to have a molecule for sugar, is C6H12O6. So what do we call substances whose properties vary or are not consistent? If you have sand that has white particles and dark particles, and you might also have pieces of soil in it. So what category would we place sand in? We would place that under the mixtures category. So it's still matter, but it's not a pure substance, it's a mixture. So substances that form when there are two or more types of particles present in the same substance, these are called mixtures. A mixture contains two or more substances that's placed together, but they do not chemically react with each other, not like compounds, okay? And they don't have a certain type of ratio. So for example, if you put some salt and pepper on a plate and you stir them around, you have a mixture. You don't have to have a certain amount of salt or a certain amount of pepper in it, but you know it's a mixture because you can see it. You can see which parts are salt, which parts are pepper. Now there are two types of mixtures. There are homogeneous mixtures and heterogeneous mixtures. So if you want to tell them apart, the word homo means same and hetero means different. So if you can tell the different parts in a mixture, then you know it's heterogeneous. If you can't tell them apart, then you have a homogeneous mixture. So a homogeneous mixture or solution appears uniform throughout. That just means that you cannot see the different substances that it's made of. Salt water is a liquid homogeneous mixture because it contains salt and water that's been mixed together so well that you can't see them as separate substances. Air is another example of a homogeneous mixture. It contains different types of gases like oxygen, carbon dioxide, and nitrogen, but you can't tell them apart. Okay, here are more examples of homogeneous mixtures. Pureed soup, coffee. So in your coffee you might have sugar and milk in it, but you can't tell them apart. Milkshake. Orange juice is homogeneous mixture unless you can see the pulp. So if next time you go to the grocery store, if you're buying orange juice, you will notice that it'll say pulp free, or it might say pulp. So it just depends on how you like your orange juice. Chocolate is also a homogeneous mixture. Cold tomato soup is another one. Now alloys are also homogeneous mixture. Now the difference between or what's important about alloys is that it is a mixture of elements, but it has the characteristic of a metal. So at least one of the mixture or substances in there is a metal. One example of an alloy is steel, which is made from a mixture of iron and carbon. Bronze is a homogeneous mixture, and it's a mixture of copper and tin. So 78 to 95% of it is made of copper, 5 to 22% of it is tin. If you have a cast iron frying pan, it's made out of iron and carbon. So 96 to 98% of it is iron, but there's some 2 to 4% carbon. Gold, so an 18 karat gold, 75% of it is gold, 12.5% of it is copper, and it might have some 12.5% silver in it. Okay, just to give it some strength. Brass is 60 to 90% copper, and zinc 10 to 35%. For sterling silver, so if you have a sterling silver ring, it's 92.5% silver, and it might have 7.5 copper in it. So now we looked at mixtures that are uniform, so you can't tell the substances that are in it. The opposite of that is a heterogeneous mixture, where you can tell the different parts. It contains two or more substances that result in visibly different parts that are not evenly mixed. Here's an example. If you add olive oil to water, you can see a mixture of two clear layers visible. The reason for that is that the oil is lighter than the water and settles on top of it. That's why if you have salad dressing, and if you have oil and vinegar, you will need to shake it, okay, in order for the oil and the vinegar to mix. Here are other examples. Tossed salad. So if you have tossed salad, you can see all the different parts. If you don't like the tomatoes in it, you can pick those out. Cupcakes is another one. Soil, granite. So mixtures where you can see all the different parts. We talked about pizza. That's another good example. The stuff that you don't like that's in it, you can pick those out. So if you don't like the olives or the onions, you can pick that out of your pizza. Sulfur and iron fillings, nuts and bolts mix. Sometimes they have them with raisins and Smarties or candies, different kinds of peanuts. So again, you can see the different parts of it, and you can pick them out. So earlier I said about the salad dressing where you have to shake it. So this is a heterogeneous mixture, but it's also known as a mechanical mixture because you have to shake or stir it to be mixed. Otherwise, if you pour it out, you're either just getting the oil or the vinegar. Well, whatever's settling on the top is what you'll get. So you need to shake it. Okay, so before we go, what I want you to do is, we have looked at everything so far. We came across the term atom, compound, pure substances, alloy, molecule, element. We just did homogeneous mixture, heterogeneous mixture, and we already looked at change of state. So the last one that we would be looking at is the physical property. So we did everything but the physical property. So what I'm going to do here is, maybe that's what's next. No, we forgot to do solutions. So solutions is a mixture formed when one or more solutes dissolve in a solvent. So if you have water and you add sugar, water is your solvent and sugar is your solute. So for example, you have a cup of instant coffee in a solution. The solid that dissolves, so the coffee granules, those are the solute, and the hot water, so that's the liquid, that would do the dissolving, so that's called solvent. So homogeneous mixtures such as solutions appear to be only one substance when you're looking at them, but you know that there are mixtures because their composition is not always the same. They don't always contain the exact same proportion. So for example, if you like a lot of cream in your coffee, but another person doesn't have as much cream or milk in it, so it won't have the same proportion, but it's still coffee. Okay, but it's not chemically bonded together. So you can try and do key questions 44 and 45. So the key question 44 is the providing the definition, and 45, you know what, we'll leave this for our next class because I want to explain this question about the glass of orange juice being a type of matter. Okay, so I'll talk to you again on Monday. Have a good weekend. Miigwech.